Philo Farnsworth is credited with developing the first electronic television system. He is a farm boy. His inspiration for scanning an image as a series of lines came from the back and forth motion used to plow a field. He is 14 years old when he came up the idea of television. He sketched the first real concept of television on a school blackboard with the transmitter, the receiver, and the design of the scanning beam. By 21, he built it and transmitted the first ever live electronic image. Television is aimed to solve the problem of limited access to news, information, and entertainment. Before its invention, people relied on newspaper, radio, and live events for these things, which were often geographically limited or less accessible. Life without television meant relying on slower, less immediate forms of communication and experiencing a narrower range of cultural experiences.
The television works by combining several scientific principles that allow it to capture, transmit, and display moving images and sound. The principle used is electromagnetic wave transmission. Television signals like audio and video are sent through radio waves. The signal is then processed for the TV to decode, and the received signals are then shown at the screen of the television, and sound is produced through speakers using vibration that converts electrical signals into audio waves that we can hear. Television relies on many scientific laws such as Faraday's law of electromagnetic induction. It is used when the antenna receives signals. This law explains how a changing magnetic field can induce a current in a wire, which is how TV signals are captured. Next is Ohm's law, in which it states that the current equals voltage divided by resistance is used throughout the TV's internal circuits to manage how electricity flows through different components. Last is the photoelectric effect, which was important in early TV cameras, describes how light hitting certain materials can release electrons, turning images into electrical signals.
Parts of the television. The television have different parts for different purposes and function for the television to fully operate. Let's first look at the parts of an early television where the system was mechanical. The Nipkow disc. It is a rotating metal disc with a spiral pattern of holes. It scanned images line by line by spinning rapidly in front of a light source. This was considered as the heart of the system. Light source. A strong light that illuminates the object being televised. The light source is placed at the transmitter's side and was essential for creating enough contrast for image capture. Photocell. Behind the Nipkow disc was a photocell, also called photoelectric sensor, which turns the varying light reflected from the subject into an electrical signal. Amplifier. The electrical signal from the photocell passes through the amplifier. The vacuum tubes boosted those signal enough for it to be transmitted. Transmission medium. The signal is typically sent to the receiver through radio waves or wire, and in Baird's first television, he used radio frequencies to broadcast images. Synchronous Nipkow disc. This is another Nipkow disc placed at the receiver end. This disc needs to be aligned to the first one precisely to reproduce the image. Neon lamp. This was the display's light source. It flickers in sync with the signal and glows dimmer or brighter, matching the image. Display screen. This made the flickering light visible to the human eye, producing a grainy black and white image. Motor. It powered both of the Nipkow discs, making them spin smoothly and at just the right speed, keeping the system synchronized. Power supply. The whole system, of course, needed electricity to power the motors, amplifiers, and sensors, and power was supplied through external cables. The television has improved over time. Now, for the modern televisions, the components are electrical. It is now more sleek, unlike the bulky design of the early television. Here are the parts for the modern television. Display panel. It is the screen where images are displayed. It can be LCD or OLED depending on the type. Backlight. For LCDs, backlight illuminates the screen. Meanwhile, OLED pixels emits their own light. Motherboard or the main circuit breaker. Central control unit housing the processor, memory, and electronic components. Video processor. This handles image enhancement, scaling, and motion smoothing for better picture quality. Audio systems. These are the built-in speakers which provide sound output. Power supply. As the TV is plugged into an outlet, the power supply converts the AC power into the DC power needed by the TV. Operating system or the Smart TV platform. This is the software that enables smart features like streaming, apps, and internet connectivity. Input and output ports. These ports are where users can connect external devices. There are ports for HDMI, USB, and such. Remote control sensor. It receives the signal from the remote control for operation. Cooling system. It keeps the TV from overheating through the use of ventilation and heat sinks. The television evolved over time. From being a mechanical equipment, it is now electrical. Let's take a look on how it evolved. During the 1920s to 1930s is the mechanical era of the television. This mechanical version required a combination of rotating discs and vacuum tubes. The system is fragile and low resolution, and it flickered. Although the first transmissions were blurry and the images was difficult to distinguish, the mechanical era was the beginning of the television. The mechanical era soon ended and was replaced by the electronic systems. In the 1930s to 2000s was the start of it, the cathode ray tubes. The cathode ray tubes or CRT replaced mechanical scanning with electronic systems which provides more reliable and clearer images. By 1950s, colored televisions was introduced, opening new viewing experiences. This version is still massive and heavy, occupying a big space in the user's homes, but it brought clarity and colors to the screen. The big designs soon got replaced with a slimmer design. The flat screen revolution started in the 2000s to 2010s. No more heavy CRT. CRTs were replaced by LCD plasma and eventually LED technology. This change made televisions thinner, lighter, and more energy efficient, and introduced 1080 pixels HD picture quality. Televisions took up less space, becoming wall-mounted as part of its modernization. The smart feature was introduced soon after, the smart TV era in the 2010s to present. Televisions are now not just about pictures and sound. They became smart devices, having an operating system which enables us to access internet, apps, stream content, and even voice control. From mechanical to electronic systems, the television has evolved greatly. From the idea of displaying moving images, it has now become the center of our entertainment.
Have you ever wondered what the first television looked like? Well, back in the 1920s, they were called mechanical TVs, using spinning discs to show tiny, blurry, black and white images. And by the 1930s, bulky CRT sets took over, giving clear pictures but weighing a ton. And in the 1950s, color televisions arrived, making the viewing experience way more exciting. But did you know that for decades, TV ran on analog signals? But that meant static noises, fuzzy images, and ghostly shadows on the screen. Well, the real game changer came with the shift to digital TV. Suddenly, pictures were sharper, sounds were clearer, and new features like subtitles, extra channels, and interactivity became possible. And it didn't stop there. Resolution leapt from black and white to color to HD to 4K, and now we even have 8K. Heavy CRTs gave way to slim LCD, LED, and OLED screens. Also, sounds evolved from weak mono speakers to powerful surrounds. And the controls? From twisting dials to remotes to voice commands, and now we even use smartphone apps. So today's smart TVs can stream movies, browse the web, and even use AI to adjust the pictures for you. So here's another fun fact. The very first remote control invented in the 1950s was called the LazyBo, and it had to be connected to the TV with a wire. So from fuzzy analog waves to crystal clear digitals, from post-age stamp screens to wall-sized panels, television has completely transformed in less than a century. So from static to streaming, what a ride for TV.
Ever thought about what TV might be like in the future? How it's gonna change and what cool features could totally switch up how we watch stuff? Let's check out the possibilities. First up, ultra-thin TVs. And when I say ultra-thin, I mean it's a piece of paper. Imagine a screen that's so thin, it feels like it's barely even there. We're talking about TVs that can be as thin as sheet of paper. It's not just about looks. This means minimalist design that fits perfectly into any room. Whether it's hanging on your wall like a piece of art or sitting on a sleek stand, this is going to take your home decor game to the next level. These TVs will have no bulky frames, just an incredibly sleek display that disappears into your space. It's all about making your living room look stylish while still giving you an incredible viewing experience. Next up, higher resolution, like 16K or beyond. We're talking unbelievable clarity. If 4K and 8K was a game changer, then 16K is going to make it look like a bareness. You could literally see every detail from the texture of a leaf to the individual hairs on someone's head. With 16K resolution, every frame looks like it was shot in ultra high definition. This is the future of ultra realism. You will feel like you're right there in the action, whether you're watching a movie, a sport game, or nature documentary. Now here's where things get fun, rollable and flexible TVs. LG has already shown us their concept of rollable TVs. And yeah, they're exactly what they sound like. Imagine being able to roll up your TV like a scroll and then unroll it whenever you want to watch something. It's super convenient for small spaces or just for people who love a clean, minimalist look. Not using it? No problem. Just roll it up and tuck it away. It's like having a huge, high-quality screen that disappears when you don't need it. Okay, let's talk about something super practical. Adjustable screen size. Imagine a TV that can actually change its size depending on what you're watching. Want to watch a movie in a huge format? Stretch it out. Just catching up on the news? Shrink it down to smaller size. The TV will adjust automatically, so you're never stuck with one static size. Whether you want a giant screen for a blockbuster or a compact one for a casual show, this is all about personalizing your viewing experience. Last but definitely not least, 3D holographic TVs. Yeah, we're talking about holograms, no more flat screens. Imagine characters, scenes, and objects floating in your living room in full 3D. You won't just watch movies anymore. You will feel like you are inside them. Interactive holograms would let you engage with the content in a whole new way. Whether it's gaming, watching, concert, or just having fun with some holographic visuals. This tech could turn your TV into a whole immersive experience. So there you have it, from ultra-thin TVs to 3D holograms that make you feel like you're in the show. The future of TV is looking pretty mind-blowing.